Hello students, and welcome to an extra video. No entry task, no launch. This doesn't match with any specific lesson from algebra or geometry. This is just something I think is really important, so I'm giving it its own video so that I can reference it later and you can watch it anytime you want, anytime you need it. This video is about simplifying radicals and rationalizing denominators. Something that my geometry students are going to use in Chapter 9, my pre-calculus students are going to use in Chapter 4, advanced algebra trig students are going to use in Chapter 5, I believe it's Chapter 5. Anywho, lots of you are going to use this. Actually, algebra students are going to use this in Chapter 9 as well. So yeah, everybody. Anybody and everybody can get something out of this video is going to need this at some point. So, I'm going to do some examples with you. I'm also going to give you some practice problems so that you can practice simplifying radicals and rationalizing denominators on your own. So, let's jump into some of the examples. Simplifying radicals. There's two different ways you can do this. I'm going to show you two methods. The first is just division, if that clicks for you. The second is we're going to make factor trees, and I'll tell you more about that on the next slide when we do method number 2. But method number 1, division. So I don't like writing out steps, but so we won't do that. But you're gonna want your perfect squares for this. You need to have memorized your perfect squares. So 2 squared, 3 squared, 4 squared, 5 squared, yada yada yada. You can have up to 12 memorized. I would encourage you to have at least up to 12 squared memorized. But these numbers on the right are called perfect squares, because when we square a whole number, that's what we get. We call them perfect squares. So what we're going to do is we're going to take the number inside the radical. Remember that a square root, whether it's a square root, a cubed root, an eighth root, this symbol is called a radical. So we're going to take the number inside of the radical and we're going to divide it by some perfect squares. And we want the biggest perfect square we can find that fits into this. So 108, we want to start with the biggest number that could fit into this. So let's try 36. Let's see, can I divide 108 by 36? Oh, we can. That was a good guess. Oh my goodness. 108 divided by 36 is 3. Now, if we had tried another number, if we had tried, say, 25, 108 divided by 25, we would have gotten 4.32. We don't want decimals. No decimals. Don't want that. So we want to find some perfect square that I can divide by and get a whole number. Now, notice that I said we want the biggest square, perfect square, because we could have done 108 divided by 9. 9 is a perfect square. 108 divided by 9 is 12. But notice that 12 can be divided by another perfect square. 12 can be divided by 4. So instead of dividing by 9 and then dividing by 4, we can do it all in one step by dividing by the biggest perfect square possible. All right, so all of that to say we divided by 36 and we got 3. That is good, because now we can rewrite the square root of 108 is equal to the square root of 36 times 3. Because 36 times 3 is 108. That's what we discovered when we divided 108 by 36 and we got 3. We said, oh, that means that 36 times 3 is 108. And you'll remember from algebra, you learned this in algebra, chapter 9, I believe, that I can split. If I have the product, a product inside of a radical, I can split that up into the product of two radicals. This works with multiplication. This does not work with addition. If we had this, oh, you can't do that. Oh, you cannot do that. But because we have multiplication, we can do that. And what is the square root of 36? 6. So, the square root of 108 is actually 6 times the square root of 3. And that's when we say simplifying radicals, it means we want some smaller numbers to work with here. The square root of 108, that's a very big number. Let's get this into smaller numbers that we can work with. Now, simplifying radicals are very helpful because this gives us an exact answer. If I typed in the square root of 108 into my calculator, I could get a decimal, but I don't want a decimal. I don't want 10.392 sometimes, because that's an approximate answer. When I get a big long decimal, that gives me an approximate answer. This is an exact answer. So, exact answers are good. All right, what I'd like you to do now, I'd like you to pause the video and try part B on your own. See how it feels. Unpause it, do it with me. Square root of 24. I want the biggest perfect square that will go into 24. Let's see. 25 is obviously too big. If I divide 24 by 25, I'm going to get a decimal because 25 is bigger than 24. So let's start with 16 and we'll check 16. 24 divided by 16. Nope. I get 1.5. Don't want any decimals. 24 divided by 9. Nope, that's an even longer decimal. 24 divided by 4. Oh, yeah. 24 divided by 4 is 6. So that means that the square root of 24 is equal to the square root of 4 times 6. Then I can split these up. Square root of 4 times the square root of 6. And the square root of 4 is 2. So our final answer is 2 times the square root of 6. All right. Now I know some of y'all are like, wait a minute. You mentioned in part A, you mentioned could divide by 4 and then divide by 9 and then too many, like, whoa. This one's confusing. That's okay. There's another way we can do this. A lot of students like this way better. A lot of students like method number 1 better. You pick the one that works well for you. The next method that works is called factor trees, or using factor trees. And what that means is we're going to take 80 and we're going to make a factor tree for it. If you don't know what a factor tree is, it means that we're going to find all of the factors of 80 using trees. And you'll see it looks like a tree when we're done. So 80. Let's see. There are many different ways that we can do this. Basically, just think of a factor of 80. What's a number that goes into 80? The two that come to my mind are 8 and 10. 8 times 10 gives me 80. So I can split 80 up into 8 and 10. Now, how can I split 8 up? I can split it up into 2 and 4. I can split 10 up into 2 and 5. Now, I can't split 2 up. 2 is the end of the tree. It's the end of the root. I can't split down 2 anymore. 4 can be split into 2 times 2, and then those end. 2, that's the end, can't split it up anymore. And I can't split 5 up anymore either, so 5 is the end. These ends are called prime numbers. I can't split them up. Their only factors are 1 and themselves. So I'm not going to split that up because it's just repeating, right? I have a 2 here. If I split it up into 1 and 2, I'm just repeating the 2 again, and we don't want to do that. So it ends with all of the prime numbers. Now, this factor tree, and you can see it looks like a tree because it's got all these roots and stuff like that. But these factor trees give us what's called the prime factorization. So this tells us that 80 is equal to 2 times 2 times 2 times 2 times 5. Right? I have 1, 2, 3, 4 2's and a 5. And I'll erase. I know I crossed them out. I crossed them out so I made sure I didn't repeat them, but now I'll cross them out. Or I'll erase that. So, 80 is equal to 2 times 2 times 2 times 2 times 5. Now this is helpful, because when I want the square root of 80, what I'm really saying is I want the square root of 2 times 2 times 2 times 2 times 5. So, anywhere you see a pair of these numbers, there are 2 2's together right here, and there are 2 2's together right here, you can pull those out front. So this is equal to 2, I pulled these out in front of the radical, times 2, I'm pulling these out front of the radical. And then the 5 is all alone. It doesn't have a buddy, so it stays underneath the radical. The radical is its buddy. So, 2 times 2 is 4. We get 4 times the square root of 5. And that's our final answer. For if we wanted to simplify the square root of 80, it is 4 root 5. Now, we could check by dividing 8 by the biggest factor. So let's see, 80 divided by 16 is 5. So 80 equals 16 times 5, which means we're taking the square root of 16 and the square root of 5, which is, square root 5. So you can use method number 1 to check if you want. But a lot of people like the factor trees because they can see visually, the 2's get grouped together. The 2's get grouped together. And you don't have to worry about forgetting or like multiplying by too small of a number or something like that with method 1. So, at this point in the video, please pause it and try part B on your own. Try these factor trees. See how you like them. Alright, we're going to make a factor tree for 128, and I'm going to start up here because this is a bigger number. It might have a bigger factor tree. So, 128 is divisible by 2, I know that. 2 and 64. And 2 is the end of that tree branch. And then we have 2. 64 is 2 and 32. 32 is 4 and 8. Oh, whoops. No, 4 is not the end. 4 is not the end. Can split 4 up into 2 and 2. Can split 8 up into 4 and 2. And we can split 4 up into 2 and 2. Holy moly! There's a lot of 2's. So, 128 equals 2 times 2 times 2 times 2 times 2 times 2 times 2. Goodness, I'm going to rewrite this a little more condensed, right? So let me make sure. 1, 2, 3, 4, 5, 6, 7 2's. 1, 2, 3, 4, 5, 6, 7. 7 2's. There we go. So this is a big number. 128 is a big number. Let me rewrite these. Okay, so another way we could write this is 128 is 2 to the 7th power. Maybe you notice that 128 is a power of 2. Anyways, if we're taking the square root of 128, we're taking the square root of 2 times 2 times 2 times 2 times 2 times 2 times 2. 7 times. So let's match up our buddies. And we have 3 pairs of 2, and we have 1 2 left without a buddy. But that's okay. The radical can be its buddy. So we're going to pull the 2 out in front. These 2's out in front. These 2's get pulled out front. And these 2's get pulled out front. And then the last 2 stays in the radical. Okay. Now, what is 2 times 2 times 2? 2 times 2 is 4, times 2 is 8. So our final answer is 8 times the square root of 2. So, at this point, I want you to pause the video and think about this. Which way do you like better? Do you like method 1, where we're dividing? We just have to divide and split it up? Or do you like the factor trees, where you can write out all the numbers, you can see them in pairs, and you can pull them out of the radical? You can only pull them out of the radical when they have a buddy. Okay, there is simplifying radicals. Here are some problems that you can practice, some radicals you can practice simplifying. And yeah, pause the video, write those down in a notebook or something like that if you want to practice. The second part of this video is rationalizing denominators. Rationalizing denominators, in my opinion, is a little simpler than simplifying radicals. And I only know of one method. So we're just going to do these 2 problems. There's not method 1 and method 2. So, in order to rationalize the denominator, that means we don't want a square root in the denominator. So, how do we get the square root out of the denominator? Well, we're just going to multiply by whatever is already in the denominator. So, for example, let's look at part A. What's in the denominator? The square root of 2. So I'm going to multiply by the square root of 2 over the square root of 2. Why am I allowed to do that? Well, square root of 2 over 2 is just 1, right? Anything over itself is 1. If I multiply 3 times 1, it's still 3. I have not changed the number or the expression. So when I multiply by the square root of 2 over 2, square root of 2 over the square root of 2, I'm multiplying by 1. And I have not changed the expression. I've just changed the way it looks. Okay. So what happens when I multiply the square root of 2 over 2? Well, remember, I multiply straight across. When I multiply fractions, I multiply straight across. So this is 2 times the square root of 2 is just 2 times the square root of 2. Can't combine them or anything like that. This is an apple, this is an orange. Can't shove them together. And on the bottom, I have the square root of 2 times the square root of 2. What is that equal to? So the square root of 2 over 2, or excuse me, the square root of 2 times the square root of 2, you can think of this as the square root of 2 times 2, right? Because we can put these together, or we can pull this apart like we did in the simplifying radicals. And this is the square root of 4, right? 2 times 2 is 4. What's the square root of 4? Oh, it's just 2. Another way you can think about this is remember that the square root of 2 is the same thing as 2 to the 1/2. So you can think of this as 2 to the 1/2 times 2 to the 1/2. Remember your exponent properties? When you have 2 terms and the bases are the same, you add their exponents. So 1/2 plus 1/2 is a whole. 2 halves make a whole. So that's 2 to the 1, which is 2. So anytime you're multiplying, square root of 2 times the square root of 2, square root of 5 times the square root of 5, square root 13 times the square root of 13, whatever the number is, if you have 2 square roots of the exact same thing being multiplied together, you can just get rid of the square root. You can just get rid of the square root. So 2, the square root of 2 times the square root of 2 is 2. And hey, look at that. I have a 2 in the numerator and a 2 in the denominator. So those cancel each other out. I get the square root of 2 over 1, but I don't need the over 1. Just square root of 2. Okay, pause the video and try part B on your own. Unpause it and let's do it together. I'm gonna erase these over here because we don't need them anymore. All right, I want to get rid of the square root 3 in the denominator. So I'm going to multiply by the square root of 3 over the square root of 3. And I get 4 times the square root of 3 over 3. And there's nothing to cancel, right? In the first one, we had the 2's on top and bottom that could cancel. This, nothing that can cancel here. So, final answer is just 4 root 3 over 3. Ta-da! Awesome! I have some practice problems in case you would like to practice rationalizing the denominator on your own. Take a screenshot of this, pause the video, write them in a notebook, whatever you want to do, but that's the end. This is the last slide. So, thanks for watching. If you have any questions, you can ask your teacher about this. I'm sure they'd be happy to help. You can text a friend. You can write it in the comments. I check comments of the videos, so you could do that. And if you're one of my students, yeah, come to office hours, after school tutoring, email me, all that jazz. So, thanks for watching. I hope you have a great rest of your day. Toodaloo!